Hello everyone, welcome back to the channel. So in the previous session, we have discussed about the formation of complex compounds and even we considered the catalytic properties. Right now in this session, we are going for the next concept of the chapter, that is formation of interstitial compounds and formation of ice. So two characteristics we are looking for. One is the formation of interstitial compounds and second one alloy formation. Well, we look for one by one. Yes, first one, formation of interstitial compounds. Well, while going for that concept, if I consider, we have heard that nothing is 100% pure. If we consider anything regarding purity, if I consider, yes, nothing is 100% pure, 100% pure. Even the purest gold, if I consider, it is about 99.9% pure, which means 99.9% pure. In the sense, what about that remaining 0.1%? That 0.1% is treated as a impurity. Yes or no? So if we consider purity wise, we won't get 100% pure substances. Even if I consider pure gold, it is just 99.9% pure. We can't say 100% pure. Yes, let's have a look here. Now, when you look at the diagram, in these two diagrams, say these are the atoms. Say it is the atoms of a constituent element, say atom, and there are some smaller particles are trapped. Yes sir, it is a smaller particle trapped in between the atoms. Whatever the gap, empty space present, say in that empty space a smaller particles are trapped. So those small particles are named as a foreign atoms. So here, if I consider without these, it is a pure. Okay, without those foreign atoms, that substance is treated as a pure. But yes, in this space, whatever the empty space present in between the atoms, there are some foreign atoms are present. They are considered as a impurity. So here, these are the atoms of a constituent element, and whatever the empty space present in between that empty space, there are smaller particles exist. They are considered as a foreign foreign atoms, or you can say particles. Some smaller particles are trapped okay at the empty space among the constituent atoms, right? In such a case, that atom, or you can say, is treated as a impure. Say where they are present, they are present at what? They are present at the interstices. What I said, the empty space is nothing but that empty space is called interstices. Okay, interstices. Well, now here, those foreign atoms, smaller particles, they are trapped at the interstices. Well, say here, in some compounds, or you can say, in another words, what we can say, the compounds having foreign atoms, the compounds having foreign atoms, where these foreign atoms present, or I can say these impure particles present, they are embedded between the, are embedded in between the interstices, and such compounds are called interstitial compounds. Okay, the compounds in which, or I can say the compounds having foreign atoms embedded in between the interstices are called interstitial compounds. Okay, well, so here if we consider interstitial compounds, what are these? They are impure substances or impure compounds. What type, how they are formed? Say here, in the crystal lattice, it is a overall, it is considered as a crystal lattice of a compound, or I can say element. In the crystal lattice, yes, there exist a large number of interstitial, or I can say interstices present. So, or I can say interstitial space present, empty space present. In these empty space, okay, in these empty spaces, a smaller particles are going to occupy, or I can say the small particles are trapped at the interstices in the crystal lattice of an element. The resultant compounds are called interstitial compounds. So when small particles trapped, or I can say embedded at the interstices in the crystal lattice of a compound, Such compounds are called interstitial compounds. Okay, well, so here some important points to be noted is, see here, when you look at the composition, okay, for any element or for any compound, yes, we'll get a composition. So sodium carbonate means what we say, Na2CO3, right? Say rock salt, sodium chloride, NaCl, we are going to specify the composition. Say calcium carbonate, Ca, okay, CaCO3, as like we are going to specify a fixed composition. But if I consider interstitial compounds, what is thing to be represented, or I can say noted here, they do not going to have definite composition. So therefore we say the definite composition cannot be represented. So for interstitial compounds, whether they have definite composition, no. So what is not an important thing to be remembered here? So the definite composition cannot be represented for interstitial compounds is the one thing, right? Then second one, the atoms that are trapped. Okay, regarding size, if I consider whatever the atoms are, the particles which are trapped, they are not too large, they are not too large nor too small. They are neither too small, neither too large. Then what it would be? Their size is nearly, okay, that size of the particle, or you can say size of the atom which are trapped, its size is nearly equal to size of the void, size of a void, or you can say that interstice. Then only such particles are going to trap at the interstices. If too large, what happens? That particle is going to remain on the upper surface. If it is too small, what happens? Such particles readily pass through that interstice and come out of the crystal lattice. If too small, they comes out of the crystal lattice, or else if they too large, they won't enter at the interstices itself. Okay, so we say regarding size of those particles, or I can say atoms which are embedded, their size neither too large nor too small. And what is the size? That size is nearly same as that of size of the void. Okay, well, if I consider two metals, say copper and zinc, these are the two metals. Well, so now say when these metals, two metals are mixed in their molten state, say we have copper in what, in the molten state, say molten copper, and zinc is also taken in what, which state, it is also, zinc is also taken in a molten state. Say in one vessel we have taken copper, is subjected for heating so that we get molten copper. In another vessel a zinc pieces are taken and is on heating, we get a molten zinc. Say now we are mixing, okay, when two metals are mixed in the which state, in a molten state, when two molten metals are mixed, what is the resultant? See, we get a something called as alloys. Okay, ಅದಕ್ಕೆ ನಾವೇನ್ ಕರಿತೀವಿ, alloys ಅಂತ ಕರಿತೀವಿ. So when two metals are mixed, okay, in a molten state, the resultant compound formed are called alloys. Well, can we mix all type of metals? No. Okay, what is the first thing here? In the formation, during formation of an alloy, what is to be, what care to be taken? Is it possible to prepare alloy by mixing any type of metals? No. Okay, what is the answer? Answer is no. Why? Say what, then what type of metals? The metals, okay, the metals in which they must have almost equal atomic radii. Okay, ಹೇಗಿರಬೇಕು, what type of metals are subjected for preparation of alloys means the metals having almost equal atomic radii can be used for the preparation of a alloys, or else it is not possible to prepare an alloy. So alloys are actually what type of mixtures they are? They are the homogeneous. What we are saying, alloys are the homogeneous mixtures. Okay, these alloys are homogeneous mixtures of two or more metals. Then how we are going to prepare alloys? When two or more metals are mixed in a molten state. What type of metals? The metals having almost equal atomic radii. When they are mixed in the molten state, the resultant compound formed are called alloys. Yes, what happens during preparation of alloys? Okay, atoms of one metal will be replaced by atoms of a other metal in the crystal lattice. So here what happened? Say if I consider either copper crystal lattice or zinc crystal lattice, copper atoms are replaced by zinc atoms and vice versa. So we are going to end up with an alloy. Yes, then if we consider node point, important node point to be remembered for alloys is the transition elements have a tendency to form alloys. Okay, regarding transition elements is they have a tendency of forming alloys. It is due to their tendencies because of the similar size. Okay, similar sizes of all elements. So as I said, necessary condition to form alloy is the almost equal atomic radii. So yes, why the transition elements they show tendency of forming alloys means because of their almost similar sizes. Okay, they readily form alloys. Next thing, so due to this, the atoms of one type are replaced by other type in the crystal lattice. So as like in the previous example I have considered copper and zinc. Copper atoms are replaced by zinc atoms in the crystal lattice and vice versa. Anything happens, resultant will be an alloy. We have two possibilities there. Copper atoms may be replaced by zinc atoms or zinc atoms may be replaced by copper atoms in the crystal lattice. That resultant compound formed will be an alloy itself. Okay. Well, then the third thing, the atoms are replaced only if. So whether it is feasible with all type of metals, as I said, no. Yes, when it is feasible, the atoms are replaced only if the difference in the atomic size is plus or minus 15%. So it is very very important. When alloy formation takes place, only when the difference in the atomic size is plus or minus 15%, then only alloy formation takes place, or else no. Okay, so if it is greater than plus or minus 15% or less plus or minus 15%, alloy formation do not takes place. Okay, yes. Now if you consider characteristics of an alloy, why we have to go for a preparation of a alloy? Though knowing wide applications of a metals, yes, why we go for preparation of an alloys? Yes, we look for the characteristics so that we get the importance of an alloy. So the first characteristics of an alloys are very hard. If you consider the physical state or strength, if you consider alloys are very hard, because if you consider metals on comparison with metal, alloys are very hard substances. So some borides, okay, some borides approach a diamond in the hardness. Some borides, okay, a kind of alloys, even it approaches the diamond in the hardness. We say diamond is the hardest substance. Say whatever the alloy prepared, kind of boride, even it is approaches the diamond in its hardness. So first characteristic is alloys are very hard in nature. And regarding melting point, say the alloys are going to have generally high melting point. Okay, melting point is too high on comparison with its pure metals. Okay, pure metals they used to have low melting point, but the alloys prepared by using those pure metals is going to have very high melting point. So it becomes an advantage of the alloys. So the second characteristic, alloys have high melting point, or I can say higher than those of its pure metals. Okay, well, next characteristic is they retain metallic conductivity. Means yes, alloys also shows metallic conductivity. And regarding reactivity, they are chemically inert. We know metals are highly reactive, but what about alloys? Alloys are chemically inert. Okay, yes, these are the few characteristics of an alloys. Yes, then coming to the MCQs. First one, what are interstices? What are interstices? Option A, the empty space between the atoms. Option B, ice particles. Option C, force of attraction. Then option D, none of the above. Yes, what is interstices? Interstices are nothing but it is the empty space exist between the atoms. It's called a interstice. Yes, option A is correct. Well, then second question, composition of impurity composition of impurity is fixed for interstitial compounds. Okay, so the composition of impurity is fixed for interstitial compounds. It means they used to have fixed composition. Is it true? Option A true, option B false, option C sometimes, and option D none of the above. Is it interstitial compounds have fixed composition? No, it is false. So what it says, composition of impurities fixed. It means they have a fixed composition. Is it true? No, it's a false. So right option is B. Okay. Well, then which of the following is property? Which of the following is a property of alloys? Option A, they are hard. Yes, it is a property of alloys. They have high melting point. Yes, it is also property of an alloy. They are less ductile. Yes, it is also property of a alloy. Then what is the answer here? All of the above is correct. Okay. Next question. The foreign particles trapped inside the interstices are. The foreign particles trapped inside interstices are. Option A, very large. Option B, very small. Option C, nearly the size of interstice itself. Then all are correct. Yes, what is the answer here? That size is neither too large nor too small. That size is almost equal to size of a wide, or I can say interstice. So what is the answer here? Option C is correct. Okay. Well, next one. During the formation of alloys, okay, during the formation of alloys, what we say, atoms of one element is replaced by atoms of another in its crystal lattice, right? So yes, during the formation of alloys, atoms are replaced only if the difference in atomic size is, the difference must be how much? Yes, look at the options. Option A, plus or minus 15%. Option B, plus or minus 25%. Option C, plus or minus 5%. And option D, plus or minus 35%. Yes, what is the answer? The difference is will be plus or minus 15%. Then only alloy formation takes place. Otherwise, no. Okay. Well, so with this, I'm going to conclude about this session. Again, in the next session, we go for other concept. Okay. Thank you. Be safe.